In this video, we will discuss a very important topic of number system, that is remainders. Now, this topic is extremely important for CAT and OMETs. In this lecture, we will only discuss the basics of remainders. Now, this topic is important for all MBA exams, whether it is XAT, IIFT, SNAP, MAH CET MBA, CVT, PG MBA, NMAT, CMAT, IIFT, or even if you are preparing for some placement aptitude, then also it is important. And even if you are preparing for some non-MBA exams like GATE, CVT, UGC NET, CSIR NET, then also it is important. So in any competitive exam, you can expect some questions on remainders. Now, before we start our lecture, I invite you to join our Telegram group. So for CAT, there is a separate group. And if you want to join for other exams like PSNET or CMAT, then also there are separate groups, right? So I will put all these links in the description. You can join them, because I will share this PDF there only and many more such PDFs, right? So it is highly beneficial for you. So I strongly recommend you to join our Telegram groups. Okay, so now let's start our topic. Now, very first thing that I will do is, let's say I take a number 8 and I divide 35 from it. Now you must have done in the school. 8 into 4, 32, and I am left with 3, right? Now here I will use a few terms. So this is known as divisor. This is known as remainder. This is known as quotient. And this is known as dividend. Right? So dividend, divisor, quotient, remainder. So these are the 4 terms that we frequently use in remainders. So how can we define this? So we can say that dividend equal to divisor into quotient plus remainder. So if I want to write this 35, I can rewrite this as 8 into 4 plus 3, right? Now one thing to note here is that my remainder is going to be always less than divisor. It cannot be equal to, or it cannot be greater than divisor, right? It has to be always less than divisor. So for example, my divisor is 8. So what are the possible remainders here? So here possible remainders are 0, 1, 2, 3, 4, 5, 6 and 7. It cannot be greater than 7, right? It has to range from 0 to 7. Okay, so you should note this point always, that, and I'm sure that you must be aware of this also. So whatever your divisor is, you cannot have a remainder greater than that, right? Or even equal to that. It has to be less than that. Okay. So now this is done. Now a very important point here, what I want to explain is that, let's say I take this dividend, okay, 35, and I take this divisor and I subtract this. So I get 27. Now what I will do is, I will keep on subtracting. I will keep on subtracting same divisor until and unless I get a number which is less than divisor. Okay, so 19, again 8, 11, again subtract 33. So now I cannot stop. Okay, why? Because this number is less than 8. Okay, so if you notice here, I got the same value here as my remainder, 3, right? Here I also got 3 and here also I got 3. So actually both the process are actually identical. The only difference is that here I am taking, if you notice here, I am subtracting 8, 8, 8 and 8 4 times, right? So that's what the quotient is here, right? So actually this process is the underlying thing in this method. But obviously we can't do this, right? Because if you take a very large number, so how many times you will subtract? So that's why we do this method. But the process is, the underlying thing is that any method of division, or you can say any method of finding remainder, is that you take dividend and you keep on subtracting the divisor until and unless you get a number which is going to be less than that divisor, right? You don't have to stop. You will not stop till that. And the number that you are going to get at last, that is your remainder, right? Now why have I explained this method? Why? Because in some topics in future you will see that we may need this topic. We may need to understand that this is how this works, right? So that's why I have explained this. Now you can call this method as successive subtraction, right? We are subtracting the divisor successively until and unless we get a number which is less than divisor, right? So you should know this method also. Okay, now let's look at a few questions. A question says, when a number n is divided by 4, the remainder is 3. The remainder when 2n is divided by 4. Okay, So we have a number n. I divide this by 4 and I get a remainder of 3. When I divide this 2n by 4, then what is the remainder? This is the question actually. Now using this definition, this dividend definition, can I rewrite this n as 4k plus 3, right? So my number is, or you can say my dividend is equal to divisor into some quotient, let's say k plus remainder, right? Now what I will do is I will plug this value here. So 2 into 4k plus 3, now divide by 4. So this is 8k plus 6 divided by 4. Right? So now my new question is, what is the remainder if I am dividing 8k plus 6 by 4? Okay. So 8k plus 6 by 4. Now I can split them further. I can say that 8k by 4 plus 6 by 4. Now 4 divides 8k, right? So from here I am going to get remainder 0. From here, what will be my remainder? If you divide 6 by 4, you are going to get a remainder of 2, right? So your answer is 2. Okay. Now one thing, you can do this, you can obviously do using this method, but I want to explain you another method as well. What I will do is, I will simply replace dividend by remainder. Okay, I can directly do that. So for example, what I'm trying to say is, this was the remainder in the first case, right? When n is divided by 4, I'm going to get a remainder of 3. Now rather than doing this whole long method, what I will do is I will simply put this 3 here. So 2 into 3 by 4. Simply I can replace my dividend by remainder. So 2 into 3 by 4, 6 by 4, and this is going to give me a remainder of 2, right? So that this is a shortcut method. So this is the strategy that we use actually. We can replace our dividend by remainder. Okay, so now let's look at another question. The question says, when a number n is divided by 7, the remainder is 3. The remainder when 5n is divided by 7. So what I will do here is, I will not explain the first method. Obviously, you can do by that way. I will simply use the second method. So n by 7 gives me 3. So 5n by 7 will give me what, right? Simply replace the dividend. Simply replace this n from the old remainder, right? So 5 into 3 by 7, 15 by 7, remainder will be 1, right? So finally our remainder is 1. Okay. Now obviously you can do the long method as well, that this method, you can rewrite this n. So you can rewrite this n as 7k plus 3, right? And further you can multiply by 5 and you can solve that further. So I will leave that as an exercise for you. That is not a hard thing to do. You can always do that. Okay, so now let's move on to the next topic. So what is the remainder in multiplication? So for example, here I have 141 into 142 into 143 divided by 6. So we have 141 into 142 into 143 divided by 6. What is the remainder? Okay, so how can we solve this? So what we will do is, we will find individual remainders for all these and I will multiply this. Okay, so when you divide 141 by 6, what you will get? You will get 3. You will get a remainder of 3. 142. Now I am not going to divide this again. This is 1 more than this number, right? So obviously I am going to get a remainder of 4. This is 1 more than this. So obviously I am going to get a remainder of 5. Okay, so what will be my remainder? 4 into 3, 12 into 5, 60 by 6. 60 by 6. Okay, so obviously this remainder is going to be 0, right? Because when I divide 60 by 6, there is remainder has to be equal to 0. So this is the strategy that we use while multiplying, by multiplication. We simply find individual remainders and we multiply those remainders and we finally find our remainder, right? So you can simply replace, actually you can simply replace the dividends by remainders. Replace numbers with remainders in product. Okay, so this way you can solve. Okay, so now let's do this one. So 75 into 76 into 73 into 78 by 34. Now 34 into 268, so this is going to give me 7, right? This is going to give me 7. This is going to give me, obviously this is one more, so this will give me 8. Now this is 3 less than this, so 5. This is 2 more than this, so 10, right? So rather than going to divide again and again, I simply used, you can say, once I found this value, the remainder from this, then I can find, using this as a reference, I can find other remainders, right? You don't have to divide again and again. I hope you got the idea. 7 into 8 into 5 into 10. So I have simply replaced all these numbers by remainders by 34. Now you simply have to do again. You have to multiply them again. Now what I will do here is, I will choose my numbers wisely. So I will take these two numbers first. 7 into 5, 35, right? Why? Because 35 will give me remainder 1, right? 35 into 8 into 10, 80 by 34. Obviously, this is going to give me a remainder 1 and this is going to give me a remainder of 12, right? So 12 into 1, that's going to be my answer. So 12. Okay. So finally 12 is our answer. So I hope the process is clear to you. Let's look at a CAT question. So this is from 2000 paper. 1421, 1423, 1425 is divided by 12. So we have 1421, 1423, 1425 by 12. Now you have to find for one number and other numbers are just two more, right? So you can find for them easily. So 12 and this will give me 1 times, so 2, 2, 1 and 10, and this will give me 5, right? 5. So if this is going to give me a remainder 5, then this will give me 7, this will give me 9, right? So 5 into 7 into 9 by 12. Again, if I multiply these two, so this will give me 35. This is the advantage, right? So this will give me a remainder of, okay, no, I have not discussed negative remainder, so I will not do that. Okay, so what I can do is, I will take numbers slightly differently. Let's multiply these two. 7 into 9, so 63, right? So 5 into 63 by 12, this is going to give me 3. So 5 into 3 by 12, 15 by 12, that will give me a remainder of 3, right? So finally our answer is 3. So you have to choose numbers wisely so that your remainder is not more, right? So let's say if I would have chosen 7 into 5, 35. So 12 into 2, 24. This would give me a remainder of 11. So 11 into 9, again I will do long. Now this is not that hard, but this is going to give me more calculations, right? So 11 into 9, 99. Again I will have to divide. So that's why I chose an easy number. So 7 into 9, 63, which is a closer to a multiple of 12, right? This is closer to 60. So that's why I'm going to get a smaller remainder, 3. So 3 into 5, 15, and that is a smaller number, so I can find my remainder 60. So that is the thing only. That is the only thing here. You should choose numbers in such a way that your remainder is as close as to, you can say 0 or 1, or you can say your remainder should be as small as you can. Okay. Okay, now for squares, when n is divided by 5, the remainder is 3. What is the remainder when n square is divided by 5? Okay, so we have n divided by 5 and remainder is 3. I am doing n square by 5. Now again same thing. See, any operations that you do on numbers, you can replace them by directly remainders. Okay, so I will simply plug this 3 in place of this n. Okay, so 3 square by 5 remainder, that will give me 9 by 5 remainder. Now if I divide 9 from 5, I am going to get a remainder of 4, right? So finally our answer is 4. I hope this is clear to you. Okay, next question. What is the remainder when 6n plus 3 square divided by 9? Okay, so 6n plus 3 whole square. Now here you can use the formula of a plus b whole square, that will be a square, so 36n square plus b square 9 plus 2ab, so 2ab 36n, right? Now if I divide by 9, okay, if I divide by 9, so what I can do is I can divide 1 by 1. So if I divide 36n square by 9, so obviously this will divide completely, right? So remainder 0, plus if I divide 9 by 9, so again remainder 0, 36n by 9, again remainder 0, so 0 plus 0 plus 0, my remainder is going to 0, right? So this is our answer. Okay, so whenever you have plus or you have minus or any mathematical operations, you can always replace it by remainders directly. Okay, so I hope this is clear to you. So what is the basic thing that we learned here actually? Now, the main thing was that any mathematical operations on numbers, okay, on numbers can be done, can be replaced, you can say can be replaced on the remainder side. Alright, so we will simply replace our numbers with remainders and do the same operations, whether it is plus, minus, right? Whether it is plus, minus, multiplication, division, a square, right? Or even cube, or any operations that you perform on numbers, you can simply do that on remainders as well, and it is going to be perfectly fine. The only thing that you have to remember is that the basic condition that you don't have to stop until and unless you get a remainder which is lesser than your divisor, right? So if you have not got, let's say you performed a mathematical operations and you did not get your remainder less than the divisor, then you have to do that again. Okay, you have to you simply cannot stop until and unless you get a remainder which is lesser than your divisor. So I hope this is clear to you. Okay, so I have some homework questions for you. So this is the first question. The question says, what is the remainder when 72 into 76 into 73 into 78 is divided by 35? So please put your answer in comments. And there is one more question actually. Okay, so this is from IIFT 2003 paper. If divisor is 12 times the quotient and 5 times the remainder, if remainder is 48, then what is the dividend? Okay, so here you can use that formula, dividend equal to divisor into quotient plus remainder. Okay, you can use this formula, but before that you will have to find a relation between these things, divisor, quotient and remainder. You have to use this information, 12 times, 5 times, and you will get some value. Okay, this is not that hard question, so please put your answer in comment section of both these questions, homework 1 and homework 2. Okay, and also please don't forget to join our Telegram group, all this CAT, TISNET, CMAT. I will put the PDF there. Okay, you can access that. So I hope you liked the lecture and it was beneficial for you. So let's meet in the second part of these reminders. Most likely we will discuss the concept of negative reminders, right? Concept of negative reminders, because this is very, very important. So thank you.